Hey everyone, welcome back to the deep dive. Today we're going to be diving into something pretty amazing and a little bit scary, to be
Oh,
honest.
yeah.
Yeah, we're talking about long duration space missions, like the really long ones.
Okay, getting into like the nitty-gritty.
Exactly.
Yeah.
And you know what really sparked this whole deep dive?
Hmm.
It was thinking about those NASA astronauts, Butch Wilmore and Suni Williams.
Mm-hmm.
They just got back from the ISS, the International Space Station.
Right, I saw that. Yeah.
So their trip was originally supposed to be super short, just 8 days.
8 days. Wow.
Yeah, like a quick trip to space and back. But, well, space has a way of changing plans, right?
Yeah, I guess you could say that.
Their little 8-day mission ended up lasting 9 months. 9 months orbiting Earth.
Oh,
Oh,
that's a long time. I mean, that wasn't what they signed up for.
right. And that's what got us thinking. What happens to humans when we spend that much time away from Earth? What's the real cost?
Yeah, the cost versus the benefit.
Exactly. Is it worth the risk? Even with all the incredible scientific discoveries they're making up there.
Well, that's what we're here to figure out, isn't it?
Exactly. So today, we're going to be looking at both sides of the argument, the pros and cons of these long-duration missions. We'll use Wilmore and Williams' experience as a kind of case study.
A very extreme case study.
Yeah, definitely. And we'll be digging through tons of reports, news articles, scientific papers.
A real deep dive, to help you understand the complexities.
For sure. Because let's be real, this stuff is complicated.
Yeah, very much so.
But it's also super fascinating. And it's something that could have huge implications for the future of humanity, for you and I.
Oh, absolutely. This is about, pushing the boundaries of human exploration.
Right. So let's get into it.
Okay, I'm ready.
So first things first, why are we even sending people on these crazy long missions? What's the scientific justification? What's the big payoff?
Okay, well, first of all, these long duration missions are crucial for preparing us for, even longer trips. Like, think Mars.
Mars. Oh, wow.
Exactly. A trip to Mars is going to be at least 18 months, and that's just there and back.
Oh my gosh.
So these missions to the ISS, especially when they get extended like Wilmore and Williams, they give us so much data on how humans adapt to being in space for that long.
It's like a real life experiment.
It is. It's about human resilience, learning how we adapt to microgravity, how our bodies change.
And all that information helps us design better spacecraft.
For
But
sure. Better life support systems, medical protocols, everything we need to keep people alive and healthy on those deep space voyages.
which, who knows, maybe one day that'll be us.
Maybe, yeah. So, NASA's Artemis program, the one aiming to build a base on the moon, that's a stepping stone to Mars.
I see, like a practice run.
Exactly. And the data from these long ISS missions, it's helping us refine everything for Artemis and ultimately for Mars.
Makes sense, but it's not just about Mars, right?
Yeah.
I mean, there's a whole bunch of other science happening up on the ISS.
Oh, absolutely. The ISS is like a giant laboratory in space. You can do research up there that you just can't do down here on Earth.
I bet. Like what kinds of things?
Oh, so many things. Wilmore and Williams, during their 9 months, they worked on over 150 experiments.
Wow. Over 150?
Yeah, they clocked almost 900 hours of research.
That's a lot of science. So, like, what specific areas are they studying?
Well, one big area is materials science.
Okay, so like how materials behave in space.
Right, because microgravity, it changes everything. So they're figuring out how to manufacture things in space, how different materials behave.
Interesting. I never thought about that.
And then there's biology. How do living organisms adapt to space?
Oh, right. Like cells and plants and stuff.
Exactly. And this can help us understand how life might exist on other planets, beyond Earth,
Oh, wow.
and even things like protein crystallization.
Protein crystallization. What's that?
So proteins, they form these crystals, and these crystals are super important for developing new medicines.
Like pharmaceuticals.
Exactly. And in space, in a microgravity, those crystals grow much bigger and purer.
Really? So that could lead to better medications for, all kinds of diseases.
Absolutely. It's a game changer for drug development.
Wow, that's incredible. So the ISS is like this incredible tool for improving human health.
It is. And then there's fluid dynamics.
Fluid dynamics, so like how liquids move in space.
Right. And that might sound boring, but it's actually super important because it can help us design better water purification system
Oh, that's important.
and more efficient fuel transfer systems for spacecraft, things that are crucial for long-duration missions.
Right. 'Cause we can't exactly stop at a space gas station.
Exactly. And, of course, they're constantly monitoring cosmic rays and
Oh,
radiation.
yeah, it's a big one.
It is, because that stuff can be really dangerous for astronauts. So they're trying to figure out how to better shield spacecraft.
To protect future astronauts.
Exactly.
So basically, every single thing they're doing up there has the potential to improve life down here on Earth.
Pretty much, yeah. It's all about pushing the boundaries of science.
It's amazing, really.
It is. And, it's not just about the hard science either. There's also the human element.
Oh, right. Like how being in space affects the astronauts themselves.
Exactly. And that's actually a really important part of the research.
I bet.
Yeah.
Because space is such a, alien environment.
It is. It's like nothing we experience here on Earth, and it puts huge stress on the human body.
I can only imagine.
So NASA, they're constantly studying how space flight affects the astronauts' health.
Like their physical health.
Yeah, their physical health, their mental health, everything. And what's fascinating is that a lot of the changes astronauts experience in space, they actually mirror certain aspects of aging and disease here on Earth.
Oh, wow, really?
Yeah, so by studying how those changes happen in space, we can gain insights into how to treat those same conditions down here.
That's so cool. Like space travel is helping us understand our own bodies better.
Exactly. It's like a fast-forward button on aging.
Wow. So, for example,
Well, one big example is bone loss. Astronauts, they lose bone density in space much faster than we do on Earth.
oh, yeah, because of the lack of gravity.
Exactly. And this bone loss, it's very similar to osteoporosis, a condition that affects millions of people.
I see. So, by studying how to prevent bone loss in space, we could potentially find new treatments for osteoporosis.
Precisely.
That's amazing.
And the same goes for muscle deterioration. Astronauts, their muscles waste away in space, and this can help us understand muscle-wasting diseases down here.
Wow. So space travel is like this unexpected key to unlocking all these medical mysteries.
It is. It's really quite remarkable.
And it's not just about the physical stuff either, right? There's the whole mental and emotional aspect of being in space for so long.
Oh, yeah, that's huge. Think about it. You're stuck in a tiny spacecraft, or even on the ISS, which is still pretty small.
With the same people, day in, day out.
Exactly. And you're thousands of miles away from your family, your friends, everything familiar.
And the Earth, your home planet.
Right. It's a very isolating experience, and it can take a real toll on your mental health.
I bet. Like, what kind of psychological effects are we talking about?
Well, astronauts can experience depression, anxiety. There's even something called Earth out of reach syndrome.
Earth out of reach syndrome. What's that?
It's this feeling of being permanently detached from Earth, like you can never go back.
Oh, wow. That sounds scary.
It can be. And even if astronauts don't experience those extreme conditions, they still miss things. Simple things like, feeling the wind on your face or jumping into the ocean.
Oh, yeah. Just the feeling of being on Earth?
Exactly. And that can be really tough to deal with, especially when you're up there for months or even years.
It makes you realize how much we take for granted.
It really does.
Okay, so we've talked about the scientific benefits of long-duration space missions.
The incredible research, the potential breakthroughs.
Right. And we've also talked about the very real risks, both physical and mental. So where does that leave us?
Well, it's a balancing act, isn't it?
It seems like it. Like, how do we continue to push the boundaries of space exploration without putting astronauts at undue risk?
That's the big question. And thankfully, it's something that NASA and other space agencies are taking very seriously.
Oh, good. So, what are they doing to mitigate these risks?
Well, one of the most exciting areas of research is artificial gravity.
Artificial gravity, like creating gravity inside a spacecraft.
Exactly. And the most promising way to do that is using centrifugal force.
Centrifugal force, so like spinning the spacecraft.
Exactly. And by spinning it, you create this outward force that mimics gravity.
Wow. That's like science fiction becoming a reality.
It is. And if we can perfect this technology, it could solve a lot of the problems associated with microgravity, like the bone loss, the muscle wasting, the cardiovascular issues.
That would be incredible. But is that even possible? I mean, it sounds pretty complicated.
It is complicated, but they're working on it, and they've made some promising progress.
That's good to hear. What about the other stuff, like the radiation and the mental health issues?
Well, for radiation, they're designing new spacecraft with better shielding. Things like water-lined walls and magnetic fields.
To deflect the cosmic rays.
Exactly. And for mental health, they're focusing on providing better support for astronauts.
Like therapy and stuff.
Yeah, therapy. But also, they're experimenting with virtual reality.
Oh, wow. VR in space.
Yeah, they're creating these VR environments that simulate Earth-like scenery.
So astronauts can, like, escape the isolation for a while.
Exactly. It's a way to help them feel more connected to Earth, to nature.
That's really clever.
It is.
Yeah.
And it shows how seriously they're taking the mental well-being of astronauts.
Which is really important. Because at the end of the day, these are human beings we're sending out there.
They are. And we owe it to them to do everything we can to protect them.
Okay, so to wrap things up, it sounds like long-duration space missions are both incredibly promising and incredibly challenging.
They are. It's a very complex issue.
And there's no easy answer, right?
Yeah. No, there isn't. But I think the most important thing is that we're having this conversation.
That we're thinking about the ethical implications.
Exactly. Because as we push further and further into space, these issues are only going to become more important.
Right. Because the ultimate goal, I guess, is to send humans to Mars.
Right. That's the dream. Yeah.
But Mars is a whole other level of challenge.
It is. It's a much longer journey.
And the risks are even greater.
They are. But the potential rewards are also greater.
I guess that's the dilemma, isn't it?
It is. And it's a dilemma that we, as a species, are going to have to grapple with.
Well, I think that's a perfect place to leave things for today. We've covered a lot of ground, and it's definitely given me a lot to think about.
Me too. It's a fascinating but also a very thought-provoking topic.
Absolutely. So, to all our listeners out there, thank you for joining us on this deep dive into the world of long-duration space missions. It's been a real journey.
It has.
And we hope you've learned something new, or at least that it sparked some interesting thoughts and conversations.
Definitely.
And with that, we'll sign off. But before we go, we want to leave you with one final thought.
A thought to ponder as you go about your day.
Given everything we've discussed, the immense potential of space exploration, but also the very real risks to the astronauts who undertake these missions, how do we, as a society, find the right balance?
How do we push the boundaries of human exploration while also ensuring the safety and well-being of those who are leading the way?
It's a question that doesn't have an easy answer, but it's a question that we all need to be thinking about.
Absolutely. Because the future of space exploration, it's not just about rockets and science.
It's about people.
It's about the human spirit.
And about the choices we make as a species, about how far we're willing to go.
And what price we're willing to pay.
So keep thinking about it, keep asking questions, and keep exploring. Because that's what humans do.
We explore.
We push boundaries.
And we reach for the stars.
And who knows what incredible discoveries await us out there in the vastness of space.
The possibilities are endless.
So until next time, stay curious.
And keep looking up.